Alright, this is day 16 of solving math problems until Hololive notices me. So here we have a system of equations once again, and this looks a bit scary at first glance, but let's go ahead and see what we can do to simplify this expression. So for the first equation, we could simply cube both sides, which will give us x squared minus xy is equal to 1. And the second equation will just say the same, x cubed plus y squared is equal to 1. And we notice there's a problem here. The fact that we have x squared minus xy is equal to 1. Here we could solve for either y or x, and it will be a hassle because of the fact that if we solve for y, we're going to get a fifth degree polynomial from the looks of it. And we want to avoid that as much as possible. So let's look at the second equation to actually see what we can do. We have y squared, so we could try to isolate x and get everything in terms of a lower degree. So let's try that. So we have y squared is equal to 1 minus x cubed. And then square rooting both sides, we get that y is equal to the square root of 1 minus x cubed. Which in and of itself kind of seems to be a problem. But since we already isolated y, we could delete the second equation, now focus on the first one. So plugging in y, we get x squared minus x root 1 minus x cubed is equal to 1. And if we add or subtract 1 and add x root 1 minus x cubed, we will have x squared minus 1 is equal to x root 1 minus x cubed. We will divide by x, and we are going to have 1 minus x cubed inside the square root. And squaring both sides, we will have x to the 4 minus 2x squared plus 1 all over x squared is equal to 1 minus x cubed. So we see that we are going to get a fifth degree either way, which is mainly the problem, right? We could go ahead and see how we could approach this problem and see what we get, but it is not going to be very simple. So let's go ahead and multiply by x squared, and we will get our polynomial. So we have x to the 4 minus 2x squared plus 1 is equal to x squared minus x to the 5. And then moving right into the left-hand side, we'll have x to the 5 plus x to the 4 minus 3x squared plus 1 is equal to 0. So now we pretty much have our second equation in terms of x, right? We have x to the 5 plus x to the 4 minus 3x squared plus 1 is equal to 0. And here we could obviously see, right, that x is equal to 1 because of the fact that here we have 1 plus 1 minus 3 plus 1, which is 2 minus 3, which is 0, which works out nicely. So we have a solution of x equals 1, and for y, we just plug in x equals 1, and we will get 1 minus 1, which is 0, so we have y equals 0. So x comma 1 and y equals 0, or pretty much the coordinate 1 comma 0. So we found a solution, and now we're going to go ahead and divide by the factor, which we will just use synthetic division to make our life fairly easy. So we have 1, and then x to the 5, x to the 4, x cubed, x squared, x, and 1. So just drops on the first value, multiply 1 by that, which will be 1, which gives 2. Multiply 2 by 1, and then 2, and 0 plus 2 is 2, and then 2 times 1 is 2 again, and 2 minus 3 is negative 1. Multiply negative 1, we get negative 1. 0 minus 1 is just a negative 1, and 1 times negative 1 is negative 1 and 0. Okay, so we get a quartic now because of the fact that we factored out our linear factor of x minus 1. So we have x to the 4 plus 2x cubed plus 2x squared minus x minus 1 is equal to 0. Okay, so let me just switch the color for it. So now pretty much this gave us x to the 4 plus 2x cubed plus 2x squared minus x minus 1 is equal to 0. Okay, and with this we could go ahead and try to use a method that we could use for solving quartics, which could either be Ferrari's method, Euler's method, resolvent, or whatever. But here, I'm just going to go ahead and use Ferrari's method. We're not going to depress the quartic or anything, we're just going to solve the solutions for this. So, we have x to the 4 plus 2x cubed plus x squared, and then it's equal to negative x squared plus x plus 1. The left side is going to be x squared plus x squared is equal to, and then negative x squared plus x plus 1. And pretty much like after we have this expression, right? Let me just go ahead and move this up. Pretty much here, right? We're going to introduce a new variable. So we have x squared plus x plus y over 2 squared. And this is going to equal to, right? And what we're going to do is also add whatever we got from this expression in terms of y and add it to the right side so that we maintain the equality. So pretty much here we're going to have negative 1 plus y x squared, right? And we will have plus x, so it'll be plus 1 plus y x plus, and then it will be 1 plus, let's see, what could we get? Okay, y squared over 4. So pretty much now that like we have all this, right? We want to make the right hand side a perfect square. And thanks to the y, we could do that, right? Because of the fact that y is going to determine a, b, c for a quadratic because we have ax squared plus bx plus c. And here we're going to simply use the fact that we have a free variable y, and we're going to use a discriminant. Delta is equal to b squared minus 4ac. Okay? And we are going to set delta equal to 0 and solve for y, right? And using the discriminant for the right side, we will have 1 plus y squared minus 4 times negative 1 plus y times 1 plus y squared over 4. And we will set that equal to 0. And now we're going to go ahead and simplify this and expand everything, which this will become 1 plus 2y plus y squared minus -1 plus y times 4 plus y squared is equal to 0. And then pretty much expanding all this, right, we will get y cubed and minus 2y squared plus 2y minus 5 is equal to 0, right? And we are going to just go ahead and simply use the formula so we don't have to deal with all the scary fractions and all that, right? So let's just go ahead and clear up some space here. Just the cubic formula flat out, right? We're going to have to use minus b cubed over 27 plus bc over 6 minus d over 2. And b is -2 and all of that, right? And c is 2 and d is -5. And pretty much if we just plug all this in, right, we are going to get 115 divided by 54. And if we also look at the second part, which is c over 3 minus b squared over 9 cubed, we will get that this is 8 over, and then since the denominator is 9, it will be, let's see, 9 cubed, that is 81, 729. Okay, so now that we have just the important information, right, y will be equal to the cube root of 115 over 54 plus the square root of 115 squared. Okay, so that will be squared, and then you'll have to add 8 over 729. And let's see, all that simplifies down to is going to be 491 over 108, and then plus the cube root of 115 over 54 minus the square root of 491 over 108 minus 2 over 3. Okay, so we see that we have a good solution to the cubic. It's not scary, it's not bad, and it's not extremely long. So we pretty much managed to see that all of this simplified down to this value right here. It's actually plus 2 over 3, not negative. And that is pretty much our solution to y, right? So also just to not like confuse you with this y, I'm going to go ahead and call these y1s. I should have done that from the start, but these y's are different from the y's in our system of equations. And yeah, so pretty much we have all these y1s, right? And since we solved our cubic in terms of y1, let me just move this over here. Pretty much what we're going to do, right, is the left side stays the same. So we have x squared plus x plus y1 over 2 squared is equal to, and then it will be the square root of 1 or -1 plus y1 x plus, and then 1 plus y all over 2 root -1 plus y1 and all squared. So pretty much now we will take the square root of both sides, which will cancel out the squares and the square roots. So luckily we now are simply solving a quadratic. So we have x squared plus x plus y1 over 2 is equal to, and we're just going to solve for the positive and negative after that. So first it will just be the square root of -1 plus y1 x, and then plus 1 plus y1 over 2, -1 plus y1. And moving to the left side, we will have x squared plus 1 minus root -1 plus y1 x plus y1 over 2, right? y1 over 2 minus 1 minus plus y1 over 2 root 1 plus y1, and that is equal to 0. Okay, so now we are solving just this quadratic. And the other quadratic is just swapping these signs, the negatives to positives. So if we solve using the quadratic formula, right, we will have x is equal to -1 plus the square root of -1 plus y1 plus or minus the square root of -1 plus root -1 plus y1 squared minus 4 times this, which I'll just write as 2, and then we'll have y1, then minus 1 plus y1 over root -1 plus y1. And then that is divided all over 2. Okay? And the other solutions are going to be complex, now that I'm noticing it. So we're going to have two complex roots. Okay? So here we're looking at our problem, right? We're not going to count the complex roots, so let's just go ahead and check what this value is. So we have that all of this expression is the two solutions for this one, right? Is x is equal to approximately 0.6642 and -0.59162. So pretty much we see that this isn't really bad necessarily because these are positive, right? And this is negative. And pretty much if we plug x into y, we're just going to go ahead and get a few long expressions, which I will quickly just clear up the screen and copy everything down there so you can see the intersections of these. So give me a minute while I do that. So we see that these are the solutions, right? And since the reason this is negative is because pretty much like if we were to verify the decimal values and if we plug this in, we see that if it's positive, it doesn't satisfy the equations, but if it has to be negative, it will satisfy our equation. So pretty much like here, our ordered pairs, right, for x1, which I will probably do in this color, right? Pretty much the ordered pairs are more than likely to be, let's say, negative, or for x1, it will be 0.6642, comma, and approximately, let's see, negative 0.8408. And the second coordinate, right, which is negative 0.59162, if we plug in 0.596 or 162, the second pair is going to be negative 0.59162, comma 1.0986.7. So pretty much we see that we have our three solutions, right? So that pretty much is it for this scary and horrifying video. Like, I was put through kind of some fun, you know? You get what I'm trying to say, right? But like overall, hopefully you guys liked it, and I really wish that May could watch this before she graduates. Like, please. Well, might as well just tag her in this video, I guess. But yeah, thank you for watching. Hopefully you liked this scary video. And yeah, this is where I say bye-bye.